Okay, this video should be short again. This is the second part of our lesson, which is 2.2 reflection. So as we've talked about before, reflection is a type of rigid motion, which means it produces congruent figures. So it's not going to change the size. It's going to stay the same shape and size. One thing that will change is the orientation. So if you may want to write that word down, that the orientation will change. And basically all that means is that it will be facing a different direction. Okay, so it'll be moved somehow to face a different direction usually. So common lines for reflection, you know some of these. I'm going to draw myself like a little coordinate plane here, and then I'm going to show you some of the lines that you're going to see really regularly. All right, so coordinate plane, some common lines for reflection. So first of all, the x-axis, that's something that's really common to reflect across. We've done that before. The y-axis as well. Sorry, I'm not drawing this super well. Two common lines that are a little different. If you have a number or a line that says like x equals a number, so I'm going to give you an example. If it says x equals 2, that line cuts through the x-axis at 2. So this is an example of the line x equals 2, and you probably need to have that drawn in your notes. If it says you're going to reflect across a y equals line, so it might say something like y equals -3, that line is going to cut through the y-axis at -3. So it's going to run this way. Sometimes those are hard for people to remember, so I would definitely make sure you have those two notes and make sure you put the labels kind of with the lines that they belong. The last two lines that you're going to have, and these are a little bit different. We're going to spend some time on these today. I'm actually going to draw these on a different picture so that you don't get confused. So we're going to move that over. The last two lines that you're going to see today are diagonal lines. These are the ones that get a little bit tricky. So there is one line that goes perfectly diagonal this way, and it's called y equals x. So it could reflect diagonally. The other one goes perfectly this way. Well, hopefully yours looks better than that. And this one's called y equals -x. So it's negative because the blue line is going down, whereas that red line is going up. Okay? Make sure you have those noted, and let's look at a few examples together. All right, so for this first example, I don't need you to draw the picture unless that is just something that will help you. I just want to explain what has been done in this picture, and we're going to write 2 bullet points for how we do reflections. So they've told us to reflect across the y-axis, so it's important that you see that. So I'm going to zoom in on our picture here and go ahead and draw for myself the y-axis. So notice we talked about this the other day. Remember, you're just counting. So for instance, M is 1 space from the y-axis, so you go 1 space on the other side to find M prime. The same for N. N is 1 space, and then 1 on the other side. Notice that P is 3 jumps from the y-axis, so we're going to jump 3 on the other side. So just so that you see, you're moving equal distances on either side. So the notes that I really want you to take for that first example is that to reflect, you need to count each point perpendicularly. Remember, that means at 90-degree angles, so you're going to count straight towards that line of reflection, and that not all points move the same distances. Notice that that's different from when we did translation, because in translation, every point moves exactly the same way. And in reflection, that's not the case. See, obviously P moved further in that last example than M or N. All right, so let's try 1, maybe 2 examples together. All right, so for this example, I've gone ahead and drawn the figure, so you can draw yourself a little sketch in your notes as well. They are asking me to reflect across the line y equals 1. Now remember, from the notes that we just did, y equals a number are lines that cut through the y-axis at that number. So this line is going to cut through the y-axis at 1, and if you want to cut through it, imagine you're using scissors to cut across the y-axis. That means this axis or line of reflection is going to go right here. This is the y equals 1 line. And now that you have that drawn, it's just like reflecting across an axis. So I'm going to go ahead and plot these points. This picture is going to kind of map on top of itself, but that'll be okay. We'll be fine there. So F is 1 away, so I'm going to go 1 the other direction and label that F prime. E, same thing. So E is going to become down here, E prime. Notice D is going the other direction, but it's still 1 away, so E and D are going to basically swap places. And G is the only one that's a little weird. Notice that G is on the line. So if you ask yourself, how far away is G from the line? You should be saying 0. So it's not going to move at all. So you may want to put a little bullet point for yourself to tell yourself that points on the lines do not move. All right, and so this example, we can go ahead and connect our final picture, and this is a little hard to see. I probably should have picked a better line, but you can see that that's been flipped over that line, y equals 1. All right, I have one more example. I promise I'm going to be quick with this last one. Okay, so this one is asking me to draw the image after a reflection over this line. So notice, I'm going to zoom in on this picture so that we can see it just a little bit better. Notice that this line is y equals negative x. It's this negative slope line. And what I want you to see is how they're counting their points, because they've already done A. So notice, you want to count perpendicularly. So if the line is diagonal, you have to count diagonal. You may want to put that as a bullet point. If the line is diagonal, you have to count diagonally. So what I mean by that is, think about A. It is, if you count diagonally, A is 1, 2 diagonal jumps from the line. So I'm going to count 2 diagonal jumps on the other side, and that's how I know where to place A prime. B is 1 diagonal jump from the line. So I'm going to do 1 diagonal jump on the other side, and that's going to give me B prime. Okay, and then C is, now notice I'm counting from C to this line right here. Okay, C is 1, 2, and a half. It's 2.5 diagonal jumps from the line. So I'm going to count a half, and then 1, and then 2. Notice that I counted 2.5 on both sides. All right, and that will tell me where I place C on the other side. And remember, always go back and connect these points and just make sure that what you have drawn is the same size as what you had before. All right, there's that note that I told you to put in there. So if you've got those last 2 examples drawn, make sure you have them drawn, then you are good to go.